Welcome. Today we're going to tackle 5-1, Day 2. And again, we're going to be spending 3 days on this section. So today is our second day. Obviously, our identities are going to get a little bit harder again. Let's go back and just do a quick review of our helpful hints. Most important thing, do not give up. Change all items to sines and cosines. Try working on one side. However, if you get stuck, sometimes you abandon it, don't erase, and try the other side, and maybe it's a meet in the middle. This skill we're going to use tonight. Also, start with the most difficult side, and don't forget your Pythagorean identities. Okay, again, we are dealing with this first 3 parts of that first column. Alright, so keep your sheet handy. Let's get ready. We've got 4 proofs to do today. Example 1. Verify each identity. Sine x over 1 plus cosine x equals 1 minus cosine x over sine x. Well, neither side looks pleasant. I'm going to declare this the harder side only because his denominator is so much more complex than over here. So I'm going to begin on this side. So, part of what I'm going to teach you today, obviously, is a new skill, okay? Because right now, you've got nowhere to go. You don't have it, everything's already in terms of sines and cosines. You don't have any of your Pythagorean identities. So, at first glance, it looks like you are stuck. So, I can try to separate it if you wanted, but that's not going to help me much. But just out of curiosity, remember the skill that we used a lot, which was, like if you had 4 plus I in a new denominator, what did you multiply by? You multiplied by his conjugate, 4 minus I. And that helps do something in this denominator. It changed the denominator, it got the imaginary numbers out. Maybe that same skill might help me in this problem. And I haven't voided any rules. I can multiply the denominator by the conjugate as long as I multiply the numerator by the conjugate. Alright, so let's do 1 minus the cosine of x. And let's see if that gets us anywhere. Maybe it will, maybe it won't. So, the numerator is fairly easy. I'm going to distribute the sign. So, sine of x times 1 is sine x. Sine x times cosine x is sine x cosine x. Now, my denominator is going to be a little bit worse. What I recommend you do is come over and do a sidebar to handle that math. Okay? My sidebar doesn't have a lot of room. I'm going to actually come up here to the top. So I want to do 1 minus the cosine of x times 1 plus the cosine of x. Alright, and I'm going to go ahead and FOIL. 1 times 1 is 1. Now I do my outer plus cosine x, my inner minus the cosine of x, the last. Negative cosine x times positive cosine x is negative cosine squared x. So what happens to your middle terms? Cosine x minus cosine x goes away, and I get 1 minus the cosine squared of x. That becomes my denominator. Did that help me, or did that just create a bigger mess? well, maybe, I don't know, there's a squared there. Maybe this guy's a Pythagorean identity. Let's see. So I'm looking for 1 minus cosine squared x. Oh, look at here. 1 minus cosine squared x is sine squared. Well, that's interesting. Alright, so I have sine x minus sine x cosine x over, I'm going to make a substitution and call him sine squared of x. Now, here's the big mistake that people like to make. They like to say, you know what, I'm just going to cross that and cross that. You can't do that because this is a family up here. Alright, so I'm going to go ahead and factor out a sine. Alright, so these do have a sign in common. So let's go ahead and factor out the sine, and I get 1 minus the cosine of x over sine squared x. Now that I have factored him out of his family, I may now simplify these. So if you have an addition, you just can't cross things out unless you factor something out. So now I agree. This sign in the numerator will take up one of them, and I'm left with 1 minus the cosine of x over the sine of x. Well, lo and behold, isn't that what I have up here? And I've survived proof 1. Okay, ready for number 2. I'm going to start a new page. You do what you want to do. This one took me about 3/4 of a page to do. So it starts off tangent x minus sine negative x over 1 plus the cosine of x equals tangent of x. Alright, so this one's going to be real difficult for you to figure out, which is the harder side. That would be sarcasm. We're starting over here. Notice this whole sine negative x. So let's actually, we're going to expand our horizons now and look at this positive negatives as well. So sine negative x is the same as negative sine of x. Alright, let's write everything in terms of sines and cosines. So tangent is sine x over cosine x minus, I can make a substitution here that this is negative sine x. I'm going to remind myself that he is over 1, and then I have this big ugly fraction in the denominator. What can I do to help clean up that numerator? And again, I apologize for the bells. I'm trying to get a little ahead in my video. Alright, can't we get a common denominator up here? So in my numerator, I'm going to have the cosine of x over. This first term already has a cosine of x, so he's good to just say sine of x. Now, do you agree here that a negative times a negative is a positive? I just did negative times negative. Now, this 1 needs to become a cosine. So do you agree I need to multiply him by cosine of x, which means I need to multiply this guy by cosine of x. So I have sine x times cosine of x. Now, don't forget, though, this is all over 1 plus cosine x. Okay? Still a hot mess. But I notice up here, what does this numerator have in common? Don't both terms in the numerator have a sign? So I think it would be a really good idea to try to factor out that greatest common factor. And in fact, I'm going to add to our little helpful hint sheet that maybe we're going to, so far some extra things we've done is we've multiplied by the conjugate. So multiply denominators by conjugates. And 8, factor out GCF. Alright, so I'm going to factor out my sine of x, see if that gets me anywhere. So sine x, when I factor out a sine of x, I get a 1, and here I have a cosine of x. All over the cosine of x, totally divided by 1 plus the cosine of x. Well, this is still a mess. So I think what I'd like to do is get rid of this compound fraction. Maybe if I got rid of it, things would at least look normal. So do you agree, again, if we need to go back, if I had 1/2 divided by 3, what would you multiply by? You'd multiply by 1/3, the reciprocal of the denominator. So in my denominator, I have 1 plus the cosine of x. So I'm going to go ahead and multiply by 1 over 1 plus the cosine of x. But whatever I do to the denominator, I do to the numerator. Alright, so let's multiply by 1 over 1 plus cosine x. Alright, so what happens down here? These all go away. Look up here. Do you agree that you can now cancel that 1 plus cosine x and 1 plus cosine x? So I get sine x over cosine, I'm sorry, I left an x off him, cosine x. Remember where we started way long ago? We were at tangent. Well, what is sine over cosine? Sine over cosine is tangent. So tangent is equal to tangent. We are done. Alright, you're ready for number 3. Alright, again, I'm going to use a fresh page. This one took me, about a half a page. Alright, so I start out with 1 over 1 plus the cosine of theta, plus 1 over 1 minus the cosine of theta. I'm trying to prove that that's equal to 2 plus 2 cotangent squared of theta. So the first question is, where do I start? And you know what? Both sides look pretty ugly. So we want to start on the ugliest side. I'm going to go ahead and run with this one because it's got the denominators. So I'm going to declare him the worst. So think back to your helpful hints. What do I normally do when I've got these two fractions with unlike denominators? Let's go ahead and get a common denominator. So this guy needs 1 plus the cosine of theta, and this fraction needs 1 minus the cosine of theta. Alright, let's get our numerators. So he had the 1 plus the cosine of theta. He needs a 1 minus the cosine of theta. Whatever you do to the bottom, do to the numerator. So do you agree that this is 1 minus the cosine of theta? Alright, let's look at this other fellow. He had a 1 minus cosine. He needs his 1 plus cosine. I cannot write. So do you agree that you have 1 plus the cosine of theta? Okay, let's clean everything up. Let's see. 1 plus 1 is 2. A negative cosine of theta and a cosine of theta is nothing. Alright, well that's improvement. I at least got a 2. How about this denominator? Can I do anything to clean him up? So if you need to, again, come over here to the side and do 1 plus the cosine of theta times 1 minus the cosine of theta, and let's FOIL. So I get 1 minus cosine theta plus cosine theta minus cosine squared theta, which gives me 1 minus the cosine squared of theta. Huh. Well, maybe he's a Pythagorean identity, right? Because he's a cosine squared. So let's see if we can find our handy dandy sheet. I think I buried mine somewhere. Alright, let's see. We're looking for 1 minus the cosine squared. 1 minus cosine. Oh, look at there. So sine squared. Alright, let's see if that substitution helps us. So I have 2 over sine squared. Huh. Well, that did not give me what I wanted. So it looks like I am stuck. So once you get to the point where you're stuck, you come back to this side and say, maybe I can get this one to look like that. Alright? So let's try. So forget about all the stuff you did over here. That's history. Now focus just on this guy. So what do I want you to do with that? Oh, wait a minute. There's an easy way and a hard way. Do you see that they have a greatest common factor of a 2? So let's try factoring that out. Maybe that'll get me somewhere. Times, so if I factor out a 2, I get 1 plus the cotangent squared of theta. Hey, maybe he's a Pythagorean identity. Well, let's take a look. So I'm looking for 1 plus cotangent squared. So 1 plus cotangent squared. Ah, look at there. He was. And he's cosecant squared. Well, what is cosecant? Isn't cosecant sine? 1 over sine? And I believe I've got there. So I get 2 over the sine squared of theta. So I have met in the middle. So this is a meet in the middle. Done. Now I got lucky, because originally that was not the way that I thought I was going to do that problem, but because I saw that cotangent squared, that was a good hint to go ahead and think that maybe it was a Pythagorean identity. So make sure you guys are always looking for that. Okie dokie. Alright, let's try the last one we're going to do in the video. Again, we'll get it started and then we'll finish it up in class tomorrow. Number 4. Cosine squared t plus 4 cosine t plus 4 over cosine t plus 2 equals 4 secant t plus 1 over secant t. Alright. Let's see if we can figure out what to do. Decide what side you want to start on. So you want to start on the worst side. So who looks worse? That side. Well, we already have a common denominator, so that's a good thing. Everything's in terms of sines and cosines, so that's a good thing. What do you think I could do up here? Let's just take a step back for a minute and ignore your sines and cosines, and let's say that you just had x squared plus 4x plus 4. Could you do anything with that expression? I think you could factor it, right? So you'd say it'd be x and x, and let's see, the last term is positive, so I want a plus plus or a minus minus, and I picked plus plus. And I want things that multiply to give me 4, add to give me 4. You guys get 2 and 2. Let's apply that to now with these cosines. So I have cosine t plus 2, cosine t plus 2, over cosine t plus 2. Can you do anything now that you have factored? Now that you've factored, you can say, this guy will cross out that guy. And I'm left with cosine t plus 2. And at that point, I'm finished. I can't do anything else with him. So what do? Go to the other side, and that's where we'll pick up tomorrow. You guys have a great evening.